Hi and welcome to this video on transformation of functions, maths made easy. Transformation of functions or transformation of graphs. Now let's have a look at this notation that we're sometimes given in exams to confuse us. This function of x. Now this normally confuses people, but all it means is it's a fancy way of saying an equation in x. So we could have this as y equals x squared. And these are all the different ways of writing the function of x. So we can use f of x, g of x, h of x, and they all mean the same thing. For example, if we have the parent function y equals x squared, then this notation, function of x plus b, would be y equals x squared, and if we had b as 2, it would be y equals x squared plus 2. In this case, it would be y equals x minus 2 squared, because the 2 is inside the argument, which is x squared. Okay, in this case it would be y equals minus x squared, y equals, and then this would be within the brackets, minus x squared, and this last example, y and the b would be 2x squared. If we're given f of x as the parent function, and the different combinations we can have with our integers and our function, with the integers or numbers in different places, then a is a stretch, so a in this position is a stretch, b is a compression, so b is a compression, c, which is inside the argument, is a horizontal shift, so c is the horizontal shift, and d, which is outside the argument, is a vertical shift. So d is a vertical shift. Let's have a look at what this means in terms of transformation of graphs. So again, if we have y equals x squared, our parabola would look something like this, going through our point here, 0, 0, and then symmetrical. F of x plus b is a vertical shift, so our parabola would be shifted up by b units, so it would be something like this, and this would be our b units. F of x minus b, vertical shift down, so we would be down here, and this would be our b units. In this case, a little bit more complicated. We have to remember this is a horizontal shift, and when it's plus b, it's not in this direction, which is right. It's shifted to the left by b units. So our parabola or our graph would go like this, and this shift here is our b units, so shifted to the left. With minus b, it's shifted to the right, and b units. This is a reflection in our y-axis, so it'd be difficult to show on a parabola. So what we'll do is, if we have square root of x as a function, which goes like this, so this would be then reflected in our y-axis, and it would go in this direction. So originally it was a dotted line, and it's been reflected. In this case, it's a reflection in the x-axis, so it would go like this. So originally it was this reflected in the y-axis, and in this last case, this a little bit more complicated. So if we show this as a stretch vertically, so if this was our original parabola, when we stretch it, this becomes more steep, this line, still going through our 0, 0 point, and symmetrical on the other side. Now let's have a look at what happens to individual points on the curve when we apply these transformations. So if we had f of x plus b, our parent function is y equals x squared, and the transformed function is y equals x squared plus 2. So that's f of x plus b, b being 2. So let's make a t-table, and we have the x here, the y, and our special points of interest: -2, -1, 0, 1 and 2. If we have the parent function y equals x squared, we get y as 4, 1, 0, 1, 4, and then y plus 2, we get 6, 3, 2, 3, 6. So we add the 2, which is b, to the y. So every point is shifted up b units. Every point is shifted up b units. The x's stay the same. We add b to our y value. So we would have y equals x squared here, and then our transformed graph move up 2 units, or b, and it would be like that. Looking at our transformation f, minus b. We have our parent function y equals x squared, and the transformation y equals x squared minus 2, where b is 2. On our t-table we do our points of interest of x and then y. For y equals x squared minus 2 minus 1, 0, 1 and 2. So our x squared is 4, 1, 0, 1, 4, and our y minus 2 then becomes 2 minus 1 minus 2, 1 and 2. Every point on the graph is moved down b units. The x's stay the same, and we subtract b from y values. Looking at our graph, we have again y equals x squared, and all our points are going to be moved down by b units. So our new graph will come down b units and back up. Y equals b f of x. Our parent function y equals x squared, and the transformed function y equals 4x squared. If we make our t-table, we have our x and our y. Our points of interest minus 2, minus 1, 0, 1 and 2. For y equals x squared we get 4, 1, 0, 1, 4. And for our 4x squared we multiply the y by 4, so we get 4y. And this would make this 16, 4, 0, 4 and 16. So notice in this case every point on the graph is stretched by b units. Every point on the graph is stretched by b units. The x's stay the same, and we multiply y value by b. Looking at our graph, our parabola for y equals x squared, we would have like so, and our transformed graph, it would be a stretch horizontally, which would make this slope steeper, so it would be coming down at a much steeper angle through our 0 and up like so. So this is y equals x squared, and y equals 4x squared. These next two transformations confuse a lot of students, so let's go over this. If we have transformation y equals the function f x plus b, and this is within the brackets, so it's affecting our we have the parent function y equals x squared, and we have our transformed function y equals, in brackets, x plus 2, where b equals 2 all squared. So let's do our t table. So again we have our x and our y. Minus 2, minus 1, 0, 1, 2. For x squared we have 4, 1, 0, 1, 4. Now this transformation actually affects the x value, so we have to subtract b from our x. So this would become x minus 2. So this would make this minus 4, minus 3, minus 2, minus 1, and 0. So what we're doing here is the y's stay the same. So the y's stay the same here, and we subtract b from x values. So the graph moves left. B units. So the graph moves left b units on our graph. So if this was our original parabola, y equals x squared, it would move left. It would move left b units. So it moved left b units, and it looked like this. So this would be our y equals x plus 2 squared. If we have the transformation y equals f, and then within the brackets a or b multiplied by our x, let's quickly see what this does to our parent graph. So say we had our parent graph. So our parent graph is y equals x squared, and our transformed graph is y equals 4x squared. On our t table we have our points of interest, x and y, minus 2, minus 1, 0, 1, 2. For x squared we have 4, 1, 0, 1, 4. Now this affects our x, so we're going to multiply x by 1 over a, which is 1/4 x. Okay, so we get minus a half, minus a quarter, 0, 1/4, and a half. So our x's are affected, the y's stay the same, and we multiply x by 1/a, and this is a compression. Looking at this transformation on our graph, a quick sketch, we'd have our original parabola y equals x squared like so, and then this compressed graph would be again going through 0, 0 and up like so. So this is y equals x squared, and this is y equals 4x squared. Finally, we're going to have a look at y equals minus f of x. So this is a flip, and we multiply the y values by minus 1. For example, if we had x, y, say we had minus 3, minus 1, 0, 1, 3. Our parent function is y equals absolute value of x. Then our new transform function would be y equals minus absolute value of x. Here we would have our y as 3, 1, 0, 1, 3. Then we multiply, so we have minus y multiplied by minus 1. We have minus 3, minus 1, 0, minus 1, 3. What if the negative affects the x itself? So we have y equals, so we have y equals f minus x. So this is a flip in the y-axis, and the y's stay the same, and we multiply x values by minus 1. So say we had the parent function y equals the square root of x, and our new transform function would be minus x, so it would be square root, the minus x would be under the square root. So we have the x, y, 0, 1, 4, 9. Let's choose numbers that we can get the square root of easily. So this would be 0, 1 square root of 4 is 2, square root of 9 is 3. Then we multiply the x by minus 1. We multiply the x by minus 1, we get minus x. So that would be 0, minus 1, minus 4, minus 9.